and record, and all attendees should be muted. All right. So, is if you increase your volume, are you able to hear me clearly from that? Okay. I'll just go out and then check. I'm just trying to see that. Yeah. Can you hear me? All right. All right. I see. Good. All right. So this was a testing of the Bluetooth, and I need to be more disciplined because the session is getting recorded, and it will be very difficult to edit the video. And Runa is online now. Runa is also attending. Okay. Great. So welcome all of you. And do I need to share my camera also here? So this is what it is. Make sense? All right. So we were trying to review your screen. Can we just close this? All right. So we were. So you are saying that you are saying that annual salary equals to raw this and tax A, tax B, tax C. All right. All right. Go down. Go down. Yeah. So you're saying so all of you. Okay. Find the bugs in it. If you think that this is correct or this is wrong. So float annual salary is less than 2.5 lakhs, then zero, tax is zero. Okay, you print something nice thing here. Else if float annual salary less than this and greater than this, greater than or equal to. Actually, equal to will go here. Anyway, that doesn't make much of a difference because it anyway inevitably will be zero. So the way you generally test all these programs, you put boundary conditions definitely in the test cases. Okay. And all right, so you have this, you have. All right, so okay, so tax amount is annual salary into this. Okay. Okay. So here you would be adding the upper one, right? Yes. Okay. Where is that? The tax you have computed above, right? Yes. For the full slab. Where are you adding the? Okay, okay. Tax amount plus float A. Tax A. Okay. Tax A is that. Yeah. Okay. 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 So your tax A is that one. Yeah. All right. The next move. Yeah, 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 yeah. Makes sense. Makes sense. Makes sense. Makes sense. Okay. Good. Excellent. Is it running? Can you show us how to run this? So we will make enhancements to this program. Keep this program safe. If you have not worked on it, make sure you work on it. Okay, because we will make and keep on making enhancements. How do we use loops on it? Then how do you use command line arguments to it? And then how do we use a dictionary in it? How do we use how do we use our other structures like functions? So we will talk about those kind of things in this context. Okay. So because I think this is a useful program, you might use it later on. Hello, sir. Welcome back.
How are you?
I'm good. I'm good.
All fine.
All fine. Yes. Okay, so enter. Let's see. What were our test cases? Enter to. Okay, to 2 point. How much is 20 lakh? Is it? It is 2.8 lakh, right? So your tax amount is 3,000. Good, good, good. And let's try again. And now enter salary as ABC. And enter salary as ABC, just ABC. Okay. Enter. So it says some error occurred. So here you need to use the try catch which we just discussed yesterday. Okay. And so you have to say try and accept. Okay. And then we say display proper error rather than just like that. Okay. All right. Now again, let's try other test cases which we discussed yesterday. So yeah. So here we are going to try 5.5 lakh. All right. So yours is 35,000. Excellent. So you can see that 0.35. Let's try 5.1 and then 9. 5.1. All right. So yours is 27,000. 27,000. Now try 9 lakh. You drag the window to up. One lakh 50,000. Great. You are correct. And try 1.1 crores as salary. 5 zeros after 110. Your answer is tax amount is how much? 36 lakhs. Yeah, that's correct. No, not 36 lakhs. It has to be 31 lakh.
Maybe I given a different use case. The last.
So here it is basically 110, right? So 110 this plus this plus this. This is correct. And then for the rest of the amount, this much. Okay. So can anybody spot an error? You are adding. How did you compute tax amount here? Why are you adding tax amount to tax amount?
I just find a zero value for the tax initially.
Okay. So it doesn't make a difference. That's what you're saying. So now your annual salary is 110 crores, right? 1.1 crores, right? Now how are you computing that one? Tax A plus tax B plus tax C plus tax D, and you are not multiplying 0.35 here. Tax D is computed on the full value. Okay. And here.
That is not 1 crore, it is 10 lakhs. That is tax D.
Yeah, these values are different. Means,
oh, okay.
For 10 lakhs.
Okay.
More than 10 lakhs.
Okay. No. So the way it is, let me go back to the specs. It says that 8 to 1 crore, 8 lakh to 1 crore, the tax is 30. Okay. So here.
Change the tax to 1 crore instead of 10 lakhs.
Oh, you use that one. Just put one more zero there. That's it. No, go down once. No, there will be one check also, right? This check. This check. Yeah, there's a if condition here. Go up. Yeah, this one. So this is correct now?
This is correct.
Yeah, this is correct.
Yes.
All right. Now try running, please. So Prithpal sir, we are basically trying to go through basics now. So what we have done is we have written a program, all of us have written a one program to do the text computation. Okay, real text computation as in based on all the correct parameters so that it is useful to all of us. Now what, can you enter once again? So your text amount is 1.05 lakh.
Tax amount is what? The 4 lakh.
4 lakh, which is wrong.
Again, it's wrong.
Can you see again?
So actually, you have not considered the last slab. You have only considered till here. 35% you are not considering.
Yeah.
No, he's considering in the average part, where the salary is greater than 1 crore.
Okay. So yeah, there are minor bugs, minor edge cases that you need to fix. Okay. So all right. So typical Python program looks like this. You have if conditions. You can do the variable assignments. And the thing which distinguishes Python is you have got a control, this command line, which you can use like a calculator also. Okay, this is where you can do anything what you can do in any programming language. You can call a function, you can do everything. So it does a line by line. Now you got the correct value?
Yes. 3195.
Yeah. Correct. Brilliant. So finally, yours is done, Baiju's done, Mitesh is done, and yours? Okay. All right. And yours is done? Text one? Yeah. So yours? See there? Okay. So yes. So we basically have done a brilliant work. The class has done brilliant job, and we are able to, in our first introduction itself, we are able to write a good enough program. And the difference between previous classes and this class is that this is going to be very hands-on. And if you have not installed Python, install Python 2.7. Go to python.org, start downloading, and then it will install. Okay. So this session is going to be very hands-on. You must have received an email on GoToMeeting. Please join the GoToMeeting so that I can immediately see your screen at any point of time. Hi. Okay, you did not receive that. Can somebody forward that invitation? Okay. All right. So there's a little difference from this one. The other difference is the session is getting recorded and I'm wearing a microphone so that I can share the video with all of you. Okay. And in your old account itself, you will see one more course on Python. Okay. Okay, I just received an email that your this thing must all your old accounts, whatever they are. I think Baiju's is only one which is now created. Your password is B capital Baiju at 123. Okay. And your login is your Gmail ID. Okay. So yeah, you can log in into it. And if you go to No Big Data and then click on login, you will see my courses. Under my courses, you will get a Java course free and a Python one. Okay. So, all right. So, okay. Who else wants to show? Who wants to show the screen?
Yeah, but let's go to meeting.
You are not joining? So all of you please join the GoToMeeting. Okay. Okay, please join that because that is very important. So we have Debashish, Mitesh. Yes.
Because it will show me non-compliant immediately.
Why?
This software is offline we have to install, huh? This software you don't need to install.
Just go to link. The link it will take.
I am default that you click on that.
Web only. It is going to web only.
This is a browser one also.
The browser one doesn't support any feature.
Is it?
You don't need it. You just need to share your screen. You don't need voice or something.
So if that is the case, will that same be not true for him?
It's true for everybody. True for everybody.
So then what do you use?
After the training, we will uninstall that. No, you need to install. Go to meeting.
As you click on the link, it starts automatically installing.
Yeah. But the go to meeting, you no need to get any, no need to do any uninstall and all.
If you are using desktop version for full control, don't use desktop version.
So you're coming from Pune?
Yeah. Now, yesterday, I got approval yesterday.
Okay.
Next week now.
Okay. All right. I'm actually a very big supporter of an online meeting because these features, right? I can see anybody's screen anytime. If somebody is stuck, I can quickly help them, and all others can also see. So it is a very healthy discussion. Yes. So see, we started with both offline, online, and we realized that offline one is online one is far better because of these small features. And in online one, people do not hesitate in asking questions. Okay, so that's another advantage. All right. So yeah, have you joined? Should I? Anybody else wants to present? Mitesh? Sridhar?
How do I share?
Okay, so yeah, so yours is working, right?
Yeah. How do you?
I'll send you the request.
Okay, I'm sharing. Never like I entered man.
Waiting to you.
Shashikant, I can see now.
Yeah.
So should I send you that? Mitesh, do you want to show? Yeah. Great. So this session is a little different where everybody is basically working along as we are talking, and all the going forward we will follow this routine only. Okay.
Anybody seeing my screen?
Not yet. It will be on this line here. Okay. If you, I've sent.
I have to download a.
Okay. Okay.
Yeah, you have to download the
So I have to download a desktop.
There's no way.
No matter what, I can't escape if I want to.
So Google Hangout and all, no. So what is the approved way of at IBM?
Actually, we are not supposed to use any this version in our
We already have our own software.
So that is only available for internal. What is the name?
Smart Cloud meeting collaboration.
Okay.
IBM Smart Cloud meeting.
But then I'll find out, oh, it doesn't work on Mac, then it'll be a problem.
No, it works.
You then never know. So.
Anybody can join that.
Okay.
And we should be able to see.
Yeah, it'll be displayed here if we can see it. Or if it is downloading, then I can give. Yeah, you can see it now. All right. So show us, is it running or not? We are able to see your screen now. So show us your code. All right. Increase the font, please. All right. So show me a little bit of font. So here what we have done is yesterday we worked on basics of programming, and yesterday we basically went through basic C if else loop, how to create a variable. Based on that, we have written a real text computation program which actually works, and so you can increase the font.
How do I do that?
You just select all, and then using view there will be something, or maybe somewhere else. I don't know how to do that. How do you increase the font? I don't know. Yeah, a little more.
More?
Control num key plus.
Visible not here.
For me it is, but can you see that? Oh, you can see from there. Okay, next up. Okay. All right, great. Now we can read it. So we see if salary is greater than this. Show me how to run and all those test cases. So my test cases are these.
2.8.
2.
1 lakh 10 crore, 1 crore 10 lakh.
Yeah.
Which is 3197.
Correct. That's my computation.
3,000.
3,000 for 28. Enter 5.5.
$35K.
Enter 5.1.
$27K.
Okay, perfect. And
Let me increase the font here.
okay, so 110. Brilliant. So yes, so his code is working fine. Anybody else want to? Okay. All right. So Sashikant, I'm making you the presenter. Are you able to join?
Yeah.
Jagdish, right? Jagjit, Sashikant, Sridhar, Baju, Mitesh, Devashish, Pritpal,
I joined.
and Rakesh. Okay.
I can see your screen.
Okay.
It's not coming there.
It is coming, yeah.
I joined.
Okay. This control plus, and I think that should be.
You know, there is a Zoom button there. It's a
Where?
go to meeting.
Where is it? Yeah, this one.
Yeah. Zoom 2. Use that. Much better.
Oh, this is better, man. Thank you. Yeah. You can close that. Press escape and then, yeah. All right. So go down and yeah, keep going down. No, that code was nice. I like that. Yes.
It's not going.
Okay. Maybe I need to scroll. That is a little problem. Yeah.
Sashikant, you can go ahead. We can see it.
So maybe Zoom to maybe 125.
I think a better thing would be to change it to
Actual size.
actual.
Scale to fit.
I think this is better.
Yeah, this is better.
All right. You okay? Are you able to go down? Scroll down. This is what is happening. Okay, actually, the resolution of this thing is smaller, so it's not fitting. That's why you'll have to increase your size. Just search for font, no? Search for font. Yeah, that was the correct one, no? Search for font. Yeah, click on that. Yeah. Here, Python one. ये बेसिक में जाओ ना, बेसिक में जाओ. Basic text font, yeah. Increase that. Click here in preview. Click edit here. All right. It looks a little better. Okay, so what you're doing is high minus low, and then you're multiplying it by a slab ratio, huh? Slab text, slab rate, and all right. Okay, so for each, basically what you're doing is you first detecting in which slab does your salary lie, and then you are multiplying with that particular value and computing it. Good, good, good. So let's try with 110 first. Can you speak up those specifications which we talked? 110. This is wrong. Slab 1, slab 2, perfect, but you have, I think, skipped. This is good actually, the way you have done. Okay, I like it because it is telling the each slab's text, and then fine.
Slab 3, 3,000, right? That is right. And 8 to 10 is also 60,000. Actually, your slab 3 is wrong here. It has to be 1 crore. You are getting just 10 lakhs. This is the upper limit.
So,
Rashid, your upper limit looks to me like 10 lakhs.
I think that's where everybody is making mistake. But this is nice. He has put all the nice things. Okay. Good.
Slab 3, you need to look at those numbers. S3 high.
S3 high, I think S3 high. And I like the fact that he has put in these, instead of hard coding the values, he has put in the variables. This is 8 lakh. This is correct. S4 high. I think S4 high has got a problem. Try S4 high.
Add one more.
And then S5 low also you have to change.
S4 high, how much? 1 crore.
1 crore, no 10 lakhs.
This is not 1 crore.
No.
10 lakhs. So this is 10 lakhs. One more.
So here it is that from here to here, this much tax. From here to here, that much tax. Here to here, that's percent, and that. This is little higher side. So first slab is 0, agreed. Second slab is 25,000, which is also correct. Second slab, which is 2%, is 60,000. This is correct. Slab 4, which is this one, is slab 4 is 81, 92. 92 into 0.3. Correct? And slab 5 is how much? Slab 5 looks awkward. 3?
Slab 5 is the problem.
Oh.
Slab 5 we don't have anything. Because there is no high idea. So,
slab 5. Oh. Slab 5 low, you have changed to 1 crore, right? So, okay, let's enter value again. I think this time okay, let's try entering again. I think try 110, then 5 zeros. Enter. Now it's correct. Yeah, actually I entered 11 crores. Okay. Good. Brilliant. So, all right. So, should we move on now? Okay. All right. So, yes. Yeah, both the things are on. One go to webinar and this thing. Because that way I can see your screen immediately. People are able to present.
From tomorrow I can access this from easily.
Yes. Okay.
One day I'll be attending from easily.
Okay. All right. So I'm using this GoToWebinar for two reasons. One, I can see your screen. Second, my voice is getting recorded in this only.
If somebody want to dial into your meeting, how to dial in?
This is that URL is there, no?
Headphone you can connect and you can speak. I think you can hear.
No, I've muted everybody.
But the dial-in details are not there.
Yeah. That I don't want to, because it's more about seeing than talking.
You paid for this or is free?
It is, I think, paid. I hope it's paid. Okay. All right. So now this, okay, so we are moving on. I'm changing myself, making myself as presenter. Okay. All right. So no questions, right, before we move forward? All right. Okay, so everybody has that command line interpreter, right? And there'll be a little lag. Okay, so we talked about so far what all we have talked about. What are the basics of program? First, we talked about how to install Eclipse, then interpreter. Then we talked about general aspect of Python. Why do we use it? Okay. So the thing is, I'll just summarize very briefly. So basically, you can execute Python code from Eclipse. So download Eclipse also. If you don't have Eclipse, then download it. If you don't like Eclipse, you can code in any other editor, say Notepad++ or Sublime Text. Those are also very good editors. And from that, you can also code. So the other thing is we have great interpreter, which you can use like a calculator all the time. So if you start that interpreter, you'll get this kind of a prompt, and you can start writing program here. This is for one statement execution at a time. So if you just copy paste all your statement into a file, that becomes your program. Okay. So far, what we have talked about is this is say your variable x equals to 10. We can write things like if x is greater than 2 and x is divisible by 2. Okay, so this is clear. Print. Okay. So it prints. Okay. So what we have done here is we have said x is greater than 2 and x percentage 2 means the remainder. If you divide by 2, if it is coming at 0, that means it divisible by this thing, and it's not counting 0 and 2. All right. In this. So this is a quicker way of, or if you have to, can anybody tell me quickly? If I have to check if x is odd, what do I need to write? If x is odd, not equal to 0. I have to say not equal to 0, right? Print odd. And I can say else print even, right? So it says even, x is even, otherwise it could have print okay. All right. So this way you can quickly, and same statement you can take it further. The important part here is there has to be an indentation. Indentation is mandatory. And it makes sure that in case you miss out indentation, it is going to give an error. Also, putting a semicolon at the end of line is not required. Okay. So, all right. And once you have written the program, you can execute a program like this. You can say, let me just go to that folder where I have stored my all programs. And so I can say I created my program yesterday. It's not this one. Not this one. Yeah. Cat hello.py. So it just says hello.py. So I can say Python hello.py. It executes it. Okay. We use, and similarly boolean.py. This was one logic which we had written, and we can again execute this program using this way. Okay. So the more important idea is that we should start using the prompt, and whatever error you get, you try to resolve it. You talked about if, else. We talked about conditions, and we talked about order of operands. Then we talked about try and except. So try and except you can use now in your program. Debashish, you can use the try and except. Okay. All right. And we also talked about conversions. For you, Sridhar, you don't have to keep converting all the time. If you have once converted into float, you don't have to again and again convert. Okay. So if you have, let us say the confusion which he's having. So let's say there was a string which you took the input from user. Let's say this is my string. Okay. And I'm taking the input from the user. This is how I'll write. Please enter your salary. Okay. And user will enter their salary. So it's asking me, so whatever I enter here, it's going into this variable, right? In your program, this is how you take your input. So here I'm saying 12.34. Okay. Right now, if you see the type of the using a function called type, you can quickly check what is the data type of string. It shows us that data type of string is string. Data type of my string is string. And to convert into, let's say, salary, so we can say salary equals float. We want it to be float. And we can say, now if you see a type of salary, what should it be? Float. Perfect. Now, if you add a float with a number, it becomes a float. If you add float with a float, it becomes a float. If you add a float with a string, what it will be? What's your guess? So if I add my salary with another float, say 1.3, it adds. And what is my salary right now? It's 12.34. Okay. Now, if I add a float with integer, so it has added one into this. Now, question is, if I add not this is a string. I'm trying to add a float and a string. What do we get? Error. So here you cannot add this way. Okay. If you want to concatenate these, okay, if you add one string to another string, you get a string. You can say Giri plus Sandeep. It concatenates. But if you want to concatenate salary and string, you would have to cast the salary into integer. Okay, you have to cast salary into integer. Sorry, salary into string. Okay, everybody okay? So that is how it works. So it's clear now? So you can keep on adding and doing all mathematical operations after one you have cast converted, after you have converted your string into float. This is where you have converted. Now you can do all the operations on it without having to again bother about it. Okay. All right. Perfect. Perfect. Now this we talked about, I think. So try except we have talked about yesterday. So try except is for handling an error. So here what's happening is we are trying to convert hello into integer, which of course is going to give us an error because hello is not an integer. Therefore, if you want to handle this situation, so let's say you want to do something in case this string contains some string. Okay. In those cases, you can just say try, do something. If some error occurs here, then do something else. Okay. In case user has entered something wrong, we can say that okay, we are assuming is I string is as 1. Okay. So this is how you do the error handling part. All right. So this is what we talked about yesterday. Now we are moving ahead and we are starting with session number 4. All of these slides are available in that uh, that learning management system.
No big data.
No big data. In your account itself, it has been added. So now you will see 3 courses, one on Java, other on Hadoop, and third one on this one. Okay. Fourth one, a video on regular expression. We are going to cover a bit of regular expression in this session also. Okay. Perfect. Now we talked about basics of for loop, if else conditions. I think those are more than sufficient. And now we are going to talk about functions. There are a lot of things which you already know, and there are a lot of things which you will get to know today. Okay. All right. So whenever you are writing a program, a large program, like for example, in our text program, there was each slab. For each slab, you were doing the same thing. For each slab, you were doing the same thing. It's just that it was too much of repetition. We wrote the same code at least 5-6 times again and again. What if we could write a small program which takes one argument as an input, which takes your slab value, starting and end point, and it also takes something called a rate and also salary, and then it returns you the text for that slab. That could have been a far better approach, so that you would not keep on doing the same thing again and again. All right. So a function, if you look at it in a classic sense, a function individually is like an independent machine where there is an input coming in and output going out. Okay. When we are saying a function takes an input in the form of something called parameters, and output is also returned. Good part about here is a function can return multiple values, not only a single value. Just the way we can pass arguments in comma separated way, we can also get the values in comma separated way. Okay, just exactly the way we pass the arguments, we receive the output. So that is one additional aspect here. If you try to do the same thing in C, C++, or Java, it's next to hell. You'll have to create one object, you have to fill in that object, and then return all these values. Here, that's not the case. I'll show you. So, all right. So here we have. So this is how you define your function. So I want to know from you. So are you able to connect with it? No.
Yeah, but when you're taking an object-oriented languages versus this, and you're telling that this is for instance, so that's
So it is object oriented. We'll cover the object oriented aspect of it also. It's just a simpler in terms of syntax. So whenever we write a program in C or C++, we define int x equals 10. Here you don't have to define the type. It automatically figures out from the right hand side. Okay, so you don't have to do the extra labor. Similarly, it basically avoids a lot of unnecessary code. Say for example, when you're starting a Java code, you have to write class, this, that, and then you have to write public static void main, which is really unnecessary. So
it will be taken as default.
yeah. So it basically has tried to make the object oriented way of working a little far simpler. As well, the strongly typedness makes people write more code. Okay, this basically takes that pain away, because you will see by how do we create object is just a breeze. Okay, similarly here, so this is clear, right? So the way we are defining a function, this is a keyword def, this is your function name, and then brackets. In middle of these brackets here, in middle of these brackets will our arguments go. My cursor is not visible. Okay. So in middle of these brackets will my arguments go. Okay. Now here, from here to here is your function definition, and note the indentation. It enforces you to write indentation correctly, and that's what makes the program neater in look wise. Okay. And you can call the function only after you have defined. You cannot call a function before you have defined. Okay. All right. So you can call this function as many times as you wish, and that's it. Okay. Am I doing a right thing? Because yeah, loops and iterations are next. So basically, rather than repeating ourselves again and again, what we have done is we have taken bunch of statements, coupled them together, and gave them a name, and that's what we call a function. And next step is that, yeah.
So if you see after thing,
Mm-hmm.
you're getting print zip.
Yes. So zip will come here. So hello fun, zip hello fun. Okay. So should we try doing it? Let's try doing it. I think that will be better, no? So is your this thing downloaded? Are you on the prompt? Are you also on the prompt? So go to python.org, download Python 2.7, and then from the command, then launch the command prompt. Okay. So on the command prompt, what we need to do is we say define, and what was the function name? Define thing, and we say enter. Then press tab and say print hello, and then say print what? Okay, print fun. And as you press the next enter, the function body completes. Okay, so you can see. So this way we can keep on defining the function the way we want. What if, and inside each function we can make a call to function itself. Okay, and what will happen in that case? So if I call thing here inside a function, what will happen?
I don't know. It should be recursion.
Anybody? So inside the function, you can do anything. I'm calling the function itself. What will happen? 2.7.
Because it is interpreted.
Mm-hmm.
So
Okay. Anybody else?
Since it is interpreter, it should not throw an error. Because
Okay.
we are defining the thing up.
Yeah, but you're calling which is not a different completely, right?
Okay. So what do you think? Inside a function I can call anything. I can call another function. I can call the function itself. Now, do you think this will work?
The argument goes to the inside.
You said something like we can make it compile code also and then
Yes. PyPy, using PyPy.
should work.
Okay. So now if I call thing,
Going infinitely.
no. It was just definition. We have not executed the function. Now we are executing the function. You can see that it has it's a overflow. All right. So it kept on executing itself so many times and did that. Okay. So that is the magic of recursive functions. Okay. So if I write ping, and inside this I'm saying ping, and there is another function which is saying we have pong. Okay. And we define pong, and inside pong we call print pong.
Yeah, because it's
Okay. And then we call ping. Okay. Now these will be calling each other. Either I start with ping or pong. Okay. Okay. So ping pong will carry on. All right.
I think this will work wonders for recursive functions.
Okay. Yeah. So I have written a lot of code using for compilers using recursion. Even my first differentiator I wrote, differentiator is an algebraic differentiator. It takes an expression, the mathematical expression, saying enter any mathematical expression, and it will differentiate it. Okay, differentiate it as in it will convert that into, say, x square is there, so it will differentiate it, meaning it will print 2 into x. So if you have put sin x, it will print cos x. If you say sine inverse of cos x, it will print all of that, cos x divided by under root square root of 1 minus sine square x. Okay, so basically most of the whole code of expression differentiation was actually infinitely simple. It was just 60 line of code, just because of recursion, just because of the functions and the recursions. So recursion, you can call inside a function, the way we are calling print. Print is also a function, by the way. Similarly, we can call the thing itself here, and it will keep on getting into the loop. All right. So this is recursive functions, and it's a lot of magic. And if you look at any of the recursive code, specifically if you look at the grammar of say a programming language, all of it is recursive code. So has anybody, by the way, read a book called Dennis Ritchie and Kernighan? KNR, Kernighan and Ritchie? Nobody? Okay. So give it a time. This is yeah. Yes. It's a very interesting book.
Yeah.
So there is one page, 2 pages basically, on recursive functions, and there it basically does wonders on those 2 pages. And have a look at that. It takes that small program does a lot of magic. What it does is it asks the user to type the declaration of a variable. You can say int asterisk x, and it will print x is a pointer to integer. So it takes any declaration, print it in English, and there's hardly 30 lines of code. Okay, so using functions and recursions, you can do a lot of wonders, and we will do a lot of wonders after a little bit of more time. And so I think we can try factorial in the next session. For example, have you ever heard about Tower of Hanoi? Tower of Hanoi? No? So in Tower of Hanoi, this is a very mythological story. So Tower of Hanoi, the problem was that yes, yes. So there are three poles. There are three poles. Okay, and yeah. So and there are discs like this. Okay, discs. So we on each pole you put the discs and you have to shift the disc. These are discs are not of the same size; they are in the star shape. You have to shift from one to another using this one as the auxiliary, such that you never put a smaller disc below the bigger one. Always a smaller has to be above the this one bigger one. So say these are the one and this one is the bigger disc and this one is smaller. So first you will take the smaller to the auxiliary, then take the bigger one into the target, and from here you can put it back. You got it, Debashish? So basically we are taking the discs from one to target using third one as the auxiliary. Why are we using third one? Because we don't want to keep the smaller disc on the bigger, or a smaller disc below the bigger one. Okay. So this kind of program, how many lines do you think you will take to solve it? Around 5 lines, yes. All right. So we will show you all of this. I think it has been what? Okay.
For Sudarshan and me, it's a kind of a black box because our basic concept has gone wrong now.
Why?
So we left long time back. I was doing a bit of almost 20 years of doing some before 10 years before I did some script.
Yeah.
Now it becomes like okay.
भूले भी चलेगी
2000 I must have done coding. 99.
Okay.
After that I've never coded.
Okay. But have you forgot when was the last time you rode the cycle?
Cycle I can ride. I'm still riding my daughter's cycle.
Okay.
That's not
And when was the last time you rode a cycle?
cycle you cannot. See the base concepts I'm still able to correlate.
Yeah.
But you ask me to sit down and
Yeah. No, I mean, same question was here, right? If you sit down on a cycle, you can ride, right? So once a programmer, does never forget that. Never
Maybe
forget.
rusty. Maybe rusty, like you cannot.
You are just hesitant.
Almost 15 years.
yeah, 15 years.
I haven't tried it.
So it's not. See the beauty of it's not like your muscle, body.
Sir, if you can put me in a pilot mode also, I can take the flight. I can take off. Landing is the only problem.
Okay. So I'll tell you what. So generally the muscles, if you say talk about your general habits, physical habits, say earlier you used to jog that much, now you are not able to. That is acceptable, but brain does not forget the things if it has tried this way. And programming is in the same way. It's just a little bit hesitant now. You start doing it, and you will be very comfortable.
So very true. Like might need some time to refresh
Yes,
everything.
yes,
Yeah,
yes,
it will take some time, but
Yes.
nonetheless, it is not
It's
impossible.
it's not impossible, and it's just this part. So the way most of the machinery and innovation works is, I'll tell you. So it works two ways. One is you get used to doing something without thinking about fruits, that will it add to my job, will it. So you just start learning these things. So say programming language, you start learning, and once you get used to it, now you get back to your normal life, and then you will realize that, oh, I can do this thing better. If you do not get into the shape of trying out, so what will happen is you faced a problem, say text computation. Instead of you thinking that I can write it, you will hunt around here and there to find an appropriate piece of code, and then you will say, okay, I could not find, you will try for 2 hours, and then you say that you'll figure out some other ways. And that way you will delay a lot of work. So the idea is that once you get comfortable, this is an exercise where you get comfortable and you start running. You start running onto it. And then in a practical life, when you face a challenge, you will be able to quickly pick it up. So this thing should become effortless. The exercise what we are doing right now is to make it effortless to switch into a programming mode from a business mode, normal routine mode. Okay, it should become your routine. Okay, and that's why I want you all to try things hands-on as we are talking. Okay, so have you tried writing a function? Did it work for you? What? So Jagdish, were you able to write a function?
Yeah.
Okay, good. So let's write a function to compute, print the minimum of the two variables, or we'll do that again in a minute. Okay. So good. So if you are able to write a very simple function of hello world, that should be good enough. Okay. Get into that shape, and so all right. So everybody, Baiju, sir, are you able to write this function? This function. Okay, it's working for you. Brilliant. For you, is it installed?
Yeah.
Great. Excellent. So this session is to make sure that we all become hands-on in programming, and okay. When I was working at DSHA, so yes, so the India MD never wrote code for last 8 years. Okay, and the guy India MD used to report to, he used to write more code than I could ever. Okay, now that was the difference. So and that was a very big difference between the way that those people operated. 3.5.
You joined after I hate.
Yes, 2002. All right.
So this program, this recursion which we are talking about,
Huh?
it auto exits, right?
Yeah, it says that total number of maximum stack
So where is that set up?
internally. So what happens is it makes a call, another call, puts it into stack, keeps on putting into stack, and when the stack size
overflow somewhere.
yes, this is stack overflow. It automatically says that
it doesn't go and consume certain sort of resources.
it tries to.
But then that is a limitation, or it is
Yeah.
a configuration set in
Yes.
Python itself, right?
Yes.
It
The
cannot
compiler
go
itself.
beyond the recursive value of 20 or 30 or what.
Correct. In the compiler itself, it is written.
Compiler.
So compiler says that the way it calls the function is, it'll take your function definition, put it in the stack, then start executing function. Then again it.
Or what you're talking was classic example of where we can use this recursive.
Correct. Lot of examples. Almost every program can be converted into recursion.
But then what happens if this exits on its own?
So see, this will be actually around 1 million calls. This is around 1 million calls.
So any program within this limit should solve the core essence of with the recursion.
Right.
What we want to achieve should be achieved within that 1 million lines is what you are.
Correct. So okay. So anybody, okay, as a teaser, this is fun. I'm going to challenge you, all of you. So here we are. Okay. So here is my function called RE. Okay. So did function work for you? Baiju? Yeah. Did it work? Okay, here is the challenge for all of you. So you can see my screen. So it says, let's say string equals.
Not keyword.
Yeah. So string equals raw underscore. Oh, it's a keyword. Yeah, you're right. Let's call it s equals raw input. Okay. And it will read from the user. Okay. Enter something. Okay. Let me just put a nice thing here. Okay. Now it will read as if s equals semicolon. Okay. Then it will print s. Otherwise, it will okay. It will call itself. Okay, so not equal to this. It is not equal to this. Okay. So okay. So now what will this program do?
It will keep on taking inputs.
It will keep on taking inputs.
Unless you enter.
Okay, so if I said SANDEEP and then semicolon, what will be the output?
Semicolon is the last.
Yeah, that is the psyche I'm looking for.
No, it will not print anything.
Why?
Because it actually goes back to the same function till the time I print semicolon.
Okay.
Will print, but this program will not work at all, right?
Why not?
It will not work.
Why not?
Yeah, I just executed the same thing.
It's okay.
Print is not. Infinite.
Is it? He thinks that it will be infinite. Anybody else?
No. Semicolon will be it will be infinite in a sense unless we will enter with the semicolon part. It will keep on asking actually.
It will keep on asking and then? No. So that is the magic about.
How you can give in multiple length SK, then it will go into the execution. Right?
Which one?
Once you press enter.
Okay, so it will read it, keep it in S, then it will check.
Not.
Okay, it's not. Then it will again call the same function, again read, again call this. It will keep on reading. The moment you put semicolon, it will end, and that particular function, and then it will go back. Now here is the magic. There is something which we all need to understand. And perfect. So he's right. It will print the things in reversed manner. This is the easiest way to reverse the lines.
Why?
Yeah. So there is something which we need to understand. Okay. So okay. You want to see? So Pritpal, you are not agreeing with me that it will do a reverse? Okay. Okay. So yeah, now it's okay. I'm saying this. It's asking me for name. So I say Sandeep, Giri, Pritpal, and say Mitesh, and we have Sridhar. Okay. Now if I put semicolon here, now you see that. So Sridhar has come before. Okay. You can see the output, right? Sridhar, Mitesh, Pritpal, Giri, Sandeep. Make sense?
Yeah, I got it.
You got it? Okay. So the way it happens is, let me try to do. How do you? Okay. Actually, I'm not able to see my icons. So, okay, let me try to find out what was it. Yeah. Okay. So I'll like to demo it here, like, okay. So on the first way, it will create an stack, and let me go back here. So it read Sandeep, right? So it will put it. So the way compiler does it is, as soon as you make a function call, when for every program internally there is a stack. And what is a stack? A stack is something in which you put one top of another, and the thing which is at the top is taken off first. Okay. So yeah. So the way a stack works is that you put something below, and on top of it you put something else, and then you put something else, and then you take off the thing which is at the top first. Okay, just like your undo history. In undo history, what is the most recent gets undone first, right? So similarly, there are lots of constructs where we use an stack similar to undo history. Here also, so a function is called first, and so here it will read the user's value and put it here, and first one would be Sandeep. Okay. Now as soon as it realizes that it is not there is another function call in the same stack, another element will be added on top of it. Okay, it's a name, and here the name would be Giri. Okay, now in the similar manner there will be another element created on top of it, and Pritipal, for example, here. Okay, and so on. The moment it encounters the semicolon, yeah. And also, I think I can draw it this way. So Sandeep is one function. Okay. After this comes this one. Okay. And Giri, and then this. So which means when Pritipal finishes, the control goes back to this one. The function in which you have read Pritipal, that function return will go to previous function, right? Because that is the guy who called this function. First function started, second function. When the second function finishes, the call will come to the first function. In the similar, and so on. So when I call a function, the call returns to me. If this A function calls B function, calls C function, okay. So when C function finishes, it comes back to B, and when B function finishes, the call comes back to A. Okay, and that's what is happening. So the way our program executed a function, right? Our program here executed a function, and when we executed thing, after that, control comes back here on the next line of that program, which means that program's variable will be here. Every function, every new instance of the function which is going to have its own set of variables. So the value of our variable S is going to be different under different circumstances. Is everybody agreeing with this output, Pritwa? So the call will come back from where it was started. So it will, similarly, if thing is calling another thing, the control comes back to that particular function. Okay? Make sense? Doesn't sound interesting? Okay. You will see more examples.
So here, scope of variable as
Is local. It is every time it's getting created.
it's easy to catch it with the scope of variable as is local to that function call. So if the function call makes another function call to the same function, again it treats as another local variable.
Right.
So once it returns back to the original function, it will hold the old value.
Correct.
That's why it is able. That's how recursion.
Correct.
It will be confusion if we see only one variable name, but its scope is different on each column.
Correct. Correct. That is why. Yeah. So everybody is okay with this now. Mitesh, Debashish. Okay. And Baju. Right, sir.
Yeah, experiment.
Okay. Good. 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 All right. Jagdish. Great. All right. Now here we are. So see, do not worry about advanced concepts. Okay. What I will focus on these basics, and these basics will make up a really, really complex program as we go forward. As we have already seen, that even the text program we saw, we were able to easily create the program. Okay. Now let's go ahead. Now there are two kinds of functions. One is built-in functions, the kind of functions which we have been using so far. For example, raw input, type, float, int. All of these functions are built-in functions. Next is function. Those we defined just now are our functions. Okay. Although internally there is no distinction between the function which are built in and function which we wrote. There is no distinction at all. But we will not use those functions right now as the new names, because that will override the old ones. All right. Now functions can take the arguments. Like every machinery takes input and gives output. In the same manner, every function can take argument. Argument is a list of things which are going into this machinery. That is the arguments. And using the def reserved words, we define the function as we have seen, and functions arguments go in this way. Okay, so this is clear, right? So this is our argument. Argument is the input to the function which we are passing. Okay, so one program can call another program, or one machinery is calling another machinery, and that machinery is passing some data to the another machinery, and that will keep on going on. Okay, so for example, here the max is basically, it gives us the max letter out of the whole word, and max is returning a value. All right, so everybody is comfortable with the function definition? No doubt, right? Okay, so yeah, this is another way what we have been telling. So hello world is an input to this machinery called max, and that is giving us the output. Okay, now inside max we could write complex stuff, like we can do everything what we have done so far. We can define a variable, we can put a if condition, else condition, or we can call another function. Okay, what we cannot do inside a function, can anybody tell? What is it that we can't do inside a function body, which we can do inside our program?
you cannot call another function inside a function.
We called.
Yeah.
So let's say my function.
I mean, exceptions or something?
No.
Break or something?
Let me first try it out. So inside a function, we generally cannot define another function. Okay. And just no, you can define. Okay. Yeah. So they basically you can define a function inside a function.
You cannot call it from outside the function. That is one part.
Yeah, we cannot call. Yeah, but you can local function to that one itself.
Scope will be local within
Yeah.
the program.
Correct. Here we can.
कोई नहीं हो सकता फिर coding.
Okay. So yeah, if I call RE and then put semicolon, so it is printing my. You can see that. Okay. Yeah, you can do that. Yeah. All right. So basically, you can do almost everything what you can do outside.
How to get W here? When I'm getting an R. Big is equal to max hello world.
Huh?
Print big. I'm getting R.
Are you right?
What's the algorithm behind this?
Are you, no, you should.
Alphabetical.
It's alphabetical ASCII value. It will give the maximum alphabetic character.
So why am I getting R? Hello world.
The reason is because you have kept W as capital.
Hmm.
If you put W as small, then you'll get that. If you see, because in ASCII value, the capital W is I think smaller than the capitals are smaller than the normal ones. Okay, so that's the reason. All right. All right. So another is that type conversions we have already talked about. Okay. String conversions. Okay. Now these are all clear, right, to all of us? So we create a function using def keyword followed by optional parameters in parentheses. We intend the body. Okay. And this is how we generally write our program. Okay. Okay. Now we can do that. Is it going back or something? All right. Now let's write a simple program which computes the average of two values. Okay. We'll create a sample program called average, and we say x comma y, and it will return x plus y divided by 2. That's pretty much. Okay. So we can say all right. So you can define your function like this, the way I have defined. This will be your first function.
So in this function you are.
So now what I have done. Yes. So what I'm trying to do here is I'm saying average x comma y return x plus y divide by 2. Return means this is going to be the output. And when I call this function AV, I can look at it this way. A equals AV, and I can say 1.0 comma 3.0. Okay. So what am I doing here is I'm calling a function called AV, which I have defined just now, and giving it two inputs, 1 and 3, and let this function. So what will happen is the moment I call it, the call goes here, x is 1, y is 3, return will be 1 plus 3 divided by 2, which means 2.0, and it'll come back. And whatever comes back gets assigned here. All right. So this is what I'm trying to do. So the input goes into first argument, second argument, and then sum it up inside the function. What does function do? This function sums up two values x and y, and does divides it by 2 and returns it. Good.
But where do you define that the value of x is 1 and the value of y?
So when I'm calling this function, whatever first argument is there, it goes to x. Second argument goes to y. Should I increase the font? Okay. So first argument goes to first argument, which is x. Second argument goes to second argument, which is y. Debashi, is that clear? Any doubt? Yeah. So what error is that? I'm making a presenter. Correct. Okay. So on the left hand side here, you have don't have to put def before that. No, that's okay. Okay. So yeah, for calling you don't have to put colon. Huh. Can you scroll up? Yes, window is little bit. No, just pull the window up. So yeah, you don't have to put 2 commas. Yeah. Remove that. Yeah, it'll work. Press enter to. Now it's work, right? So he was calling the function with using def keyword, which is not correct. Okay. So everybody is able to write a function of average. No? What is the error you are getting? Let me try to make you.
Can you just show your program one? Is it the same one?
Here.
The Python console one.
So there is a tab here.
Yeah, that I got the 2 pointers. I'm just trying to find out that a equal to ab whatever doing, right?
Yeah.
So what value it is going to be?
A. So it's going to sum 1.0 and 3.0 and then divided by 2 and put that value into this variable called A.
That is the only function, right? Nothing like we are defining another variable A.
Yes.
If you type that A, it will automatically give the average value.
So here A does not mean A is not a function, A is a value. Okay. A is a value returned by the function. We basically caught that variable, whatever has been thrown by AV, we have caught it into A. So A is that location containing that value returned by the function. Yes, Baiju, is it working now? Okay. Sir? So I can't see you in that thing.
He didn't log in. Okay. So here you don't need to give that semicolon. Here? Just copy paste.
No, I'll first define average. Your function is defined?
Yeah.
Run Python, na, first.
No, I'm just calling this file directly.
Okay. I'll tell you. Go back here. So here you have this is fine.
Yeah.
So now you have to remove the indentation because you are out of that function.
Okay.
And then rest is okay. It's only the indentation problem. So now this
comma,
means
right? Oh.
now this means now it's okay. No, you have to print out. So whatever value is coming here, let's say A equals this, and we say print A. Yeah, say print A. Perfect. All right. Is it working for you? Great. All right. Perfect. So everybody is able to. All right. Good. So actually indentation का problem था. No other. It was only indentation problem. So you are not into this. You are not here. Go to meeting. Okay. No, but whenever I need, I'll give you the presenter only when it's required. No. Only until you say okay. Yeah. You can select the window which you want. All right. So that was what we had talked about. All right. Okay. So now we have learned how to pass the argument. Okay. We can do a lot of cool stuff. One is, let's say we want to sum up a value up to 100. Okay. How will you sum up value up to 100 using whatever we have learned so far? So for 100, what you do is take 100, then sum up with 99, then sum up with whatever. So we can say definition, sum, and whatever value people give, or sum up to. Okay, sum up to. Okay, whatever value people give, we can sum up to this. How? Value plus
Value minus 0 until 0.
sum up to value minus 1.
But you have to break.
If value equals 0, you just return 0. Okay? Else return. Okay? Or you can say simply like this, and you can say okay, or in a better way you can say total. We are going to do some magic with whatever we have learned so far, and we can say total equals value plus. So what does it do? What we are doing here is we are trying to write a function which takes a value and sums up everything up to this. So 100, if you pass 100, it will give you 100 plus 99 plus 98 plus 97 and so on. Okay. So sum up to this value, this is what it is going to do. Is it clear to everyone? If value is not 0, only then call further. Not exclamation. That's exclamation. All right. So now it will sum up to that value. Although there is a formula, you were right. Yeah, this is tail recursion. Now you can see that this is not correct. We have to return total here, not value. Okay. Okay. Now you can say sum up to and you can say 100. Okay. The formula is the other way we could have done is the other way. Can you code that somebody? So other function could have been sum up to let me call it 1. Okay. And how do we generally do this kind of thing? We'll say return value into value plus 1 divide by 2. Correct? And if I want to call this, you can see that both functions do the same thing. This one uses that formula which we read. Sum up to n is n into n plus 1 divided by 2. And the first one uses recursion to solve our problem. Okay. So is it working? Everybody okay with this? Okay. What error does it give? I made you presenter. Say 100 here. Sum up to is not defined. T should be smaller. The way you're calling, right? You should. So your function says U capital, T smaller.
Value 1000. Correct.
Loop. Put in 5. If it is going in the loop for 1000, it'll go for a loop in 5 also.
No. I don't get for 999 also.
Okay.
Right?
So let me try. So you are saying for 1000. It says you are correct.
That is why.
Huh?
Limitations of recursion.
Oh, this is strange.
When you put 999,
Up to 998, it's okay.
put 999.
Yeah, I see that. Okay. So the recursion depth is 1000.
Change it. That's a Python. If it's in a compiler, you should be able to change it. Right?
No, I think there'll be a switch to turn on the that part.
It has to be. Otherwise, you're limited, right?
Yeah.
Or it's
Increase
not an enterprise level language.
stack size by 3. So if I change this, I think then it should be work. So you can basically change it. Yeah, now it's working fine. All you need to do is change the limit to a bigger size, and that's it. Okay, you can say import sys, and then you can say sys dot set. Okay, sys. You can say sys get recursion limit. It says this much. Okay, for you it will be 1000 by default. So now if I run it again, see, by default it is 1000 only. 1000. And why it's only giving 98? Because first one is your program, and that program has called the other program. So there is for total 1000 stack.
So the program itself will take some stack.
One stack. Perfect. So we are all on the same page. Yes. So, okay. So can somebody come up and tell me how to write a factorial program? Okay, tell me.
Maybe you could.
Okay, so I'll ask somebody else. Okay. Pritpal, how would you write a factorial program? Okay. No, it's not that. It's actually easier than this. Okay. Factorial is, who knows about factorial? Yes. Tell. So factorial is, factorial of n equals n into n minus 1 into n minus 2 and so on. Okay. So you can write the factorial in the same manner, right? So can somebody dictate to me? Def fact val colon if val equal to 1 return 1 else return val star fact val minus 1. Do you think this line is required? Not required. Correct? Because when things have returned, it will anyway not get into. So, do you think this code is correct? Anybody? Huh? So, what happens in case of fact 0?
Fact 0 is there. Okay, with val less than.
Is this okay, Pritpal?
Can you run this one? I was getting an error actually. Like the multiplication.
Yes. Let's say I'm saying 1. I get 1. If I say 2, I'll get 2. If I say 3, what will I get? Now 4. It will be the 4 into the previous value, right? 4 into 6. And 5 will be 120.
If val less than or equal to 1.
Now, if it is 0, then it gets lost. Okay, so you have to.
Factorial 1, right?
I think 0 factorial 1.
No, val less than or 1.
Less than or equal to 1.
Yeah, so now it will be correct. Okay, so everybody okay with the factorial also? The previous one, everybody was able to do this one. Show me the screen. Okay. I'm making a presenter. Yes, show me the screen. All right. So this is probably the best way to learn programming as compared to learning the theory, is by trying it out and not giving up. Okay. All right, this is good. So sum up to this value and you're converting it into value, then total equals 0. If value is not equal to 0, then also in the return, right? You don't have to put indent because what's happening is this return is inside that if condition. Okay. And also leave one line space, that will make it clear. Before and after if, you should leave one line space. Yeah, that's it. I think that should work. Also, this is a very good way of working where you have two windows open and in one window you are coding and another window you are trying out. Okay, this is also a good way of working. And so so everybody comfortable with this factorial and summation up to n number? Okay. Mhm. Mhm. So this was not really a problem. The problem was that it is a logical problem. It was returning inside if condition. Perfect. Awesome. So great. We are doing very great. So everybody is on the same page. Devashish?
I was just missed the factorial part.
Okay. Factorial, you can have a look here. So what we are trying to do is fact value. And in fact value, if value is less than or equal to 1, we return 1. Okay. So if you give it 1, it will return 1. If you give it 2, then it goes to the next line. Okay. Or an easier way would be, I'll say this, and I'll say previous factorial equals this, and then return previous factorial. Okay. So I computed the factorial up to this, and then whatever result I get, I'll put it.
If we get to know why it is previous factor, then we understand recursion.
Yeah.
Why it is previous factor? That is the
So what we did was we are calling itself. This is clear now?
Yeah.
Sir?
Yeah.
Is this clear now?
On one side. Keep that screen on for a minute and just let me.
Okay. Can I just put it on the chat? Yeah, the problem is that it screws up. It has removed all the tabs.
Can you put that code, text code, into chat?
Which one? This one?
No, or first one, text code.
Oh, that one. This one? Text one. Okay. I'll write the specs for you. Yeah. I did not write. I wrote my version. You have to write your version. Okay. Or you can cheat.
Yeah, you can paste this.
Okay. So this is okay. These are the specifications, and the test case is here. For 2.8, the value is this. 110, the value is this. Okay. And all right, I'll just send it to all. Send it to entire audience. So this is the text computation screen. And I'm hoping my recording is working. Yeah. All right. Sounds good to you? Everyone? That will be looking really awkward in the chat. That is it looking awkward? In the chat, there is a chat window. नहीं एक काम कर सकते हैं. I mean, we can take my plan is that the total training is of 26 hours. Okay. So 8 hours yesterday, 8 hours today, and a little more, maybe a little more today, and maybe a little more day after tomorrow. Tomorrow we can take a break.
Tomorrow, Friday, Friday, 26 hours, right? Yeah. तो हम लोग Friday को ही खत्म कर लेंगे, Thursday को ही खत्म कर लेंगे. Friday. Sandeep, you are covering the
want to finish by next Thursday, because next Thursday I will be flying back.
Okay. Next Thursday will be difficult because my plan with R is from Monday to Friday. Monday to Thursday is good. Monday, Tuesday, Wednesday. Yeah, that's good. I think Thursday it will. I'll finish. Monday, Tuesday, Wednesday, Thursday. 4 days, na?
So you are covering that.
We'll cover that. Yeah. Okay.
We can do one thing. Don't do anything. Today and tomorrow, we will complete this Python.
And Friday you'll be off?
Friday.
No, I need a little break. I'll take a break tomorrow and then we'll take on Friday.
Okay, so tomorrow we are not having class.
No, we're not. Okay. Okay. What?
But
So you don't like it?
Sandeep, are you recording all this?
Yes.
Then better you share that.
Yeah, everything will finish. No worries. Okay.
Don't mind, do you have any topic list that you are going to cover?
Yes, yes. So I've already put
Already kind of,
right. So yeah. So let's move ahead. I'm moving a little slow now, so that now I will pick up a little more pace. Okay. Because now everybody is comfortable, and now as I move forward, people will be trying out by themselves.
Okay. Here you have used function called return, right?
Yeah.
So how is it different from print?
Return is returning a value.
Returning a value.
Yes.
So what if I'm putting that in one of the variables and same formula I'm putting there and I'm printing that variable. For example, you have given an example right where you have defined x and y, and then you have put return x plus y divided by x.
Just a second. Let me have a look at your screen. Okay. So, all right. Make myself presenter. So you are the presenter right now. Huh?
So what I'm telling you is, okay, and then average, and then x and y.
Okay.
And then, plus y divided by 2 print. Right?
Yeah. Yeah.
So that's why it's
Okay. Now you say x equals to AB.
so I've write here
Yeah.
where after print.
No, come on. Yeah. After print. Outside the function, which means press one more print. Enter. Now write x equals AV. Yeah. Basically call the function with 2, 2. 2, 2. Yeah. Will it work? What will be the now in the next line say print x. What will be the result?
If I comment out the first one, no, okay. So okay, we are calling that also here also, right?
Yeah. So run your function. Run all of it.
Straight away to 2 and then none.
Correct.
Yeah.
Why? Because x, your function did not return any value. Your function did not return any value. That is why x is none. Now print goes to your screen and return goes to the variable to which you are assigning your function. So here, if you had return value, now instead of print, say return. Yeah, say return. Now the value will come in x. You can see that. So that is the essence of return. Print goes to the screen, while return goes to the variable which is being assigned. Okay. All right. Now I'm moving on. Okay. Okay. Now there is something called returning multiple values. Okay, returning multiple values. So I'm just thinking, can I code everything using my recursion, finding the maximum value or not?
Maximum of an array.
Now let's say you want to swap two variables. Okay, or you want to sort two variables. Okay, let's say you want to sort two variables x and y, and so in those cases you will use the multiple argument. The way we are returning one value, we can return multiple values from it. And the way we can do is using such kind of function. You can see return min comma max, and when we run this function, we will get min comma max. So we can see that we can say define, we call it order, okay, x comma y, and colon, we can say if x is greater than y, return y comma x, otherwise return x comma y. Okay, now if you say order 3 comma 4, you'll get correct, and again if you say 4 comma 3, you will still get it ordered those two values. Okay, now you can also assign them into some variable. Say a comma b, we can assign it. So a will be, anybody?
Sorry?
So we can assign,
Yeah, A will be 2 and B will be 4.
okay? So instead of only returning, the way we were passing multiple arguments to the function, in the same way we can return multiple values from the function. What we are doing, in case x is greater than y, return y comma x, and otherwise return x comma y. So it will order the values every time. Yes. So else also, yeah, because from if it will anyway jump. It's not going to come below. Okay. It will anyway return from the function outside. It is not going to execute the next statement. Okay. All right. This is clear. So this way, this is a very useful thing, and I absolutely love this kind of thing, because in other programming language, it becomes a very difficult thing to return multiple values. Okay.
I don't think anybody is supposed to.
Hmm?
Are there any programming language that's supposed to return?
Not yet. I don't know. So people return. Now you can see that A and B we have assigned in a single shot. Okay. So this is a very, very useful feature. Sounds good?
Yeah.
And this loop, if you can see that there is a loop here which basically goes through it. Okay. Now there is something called variable number of arguments. So far we defined arguments. Okay. Now you will see a program. Say for example, do you use DOS? When you execute a program, main function, we'll talk about it. All right. So okay. So in case you don't know how many arguments are going to be passed to your program, right now if you don't know, then you can take care of that by defining it this way. You can say define many arguments function, and you can accept any number of arguments. So we talked about functions where we were taking 2 arguments. We talked about functions where we did not take arguments. And in the similar spirit, we can have a function which can take any number of arguments. We are not predefining it. We are not restricting it. In that case, all you have to do is put a asterisk and say arg. And that's it. So you can after that, you can basically, the arg is a list that will come to you. Arg is a list that will come to you. And now you can iterate over arg and do whatever you want. If you want to find out length of a arg, then you can do that. If you want to say, give me this portion of the list, then you can do that. Okay? So that is the variable number of arguments.
Why do we need a pointer?
It's not pointer, it's just a symbol.
Because simply say arg was right.
So in those cases, if you simply say arg, then it will be a single argument. So I'll show you what I mean by it. Say I'm trying to, okay? I'm trying to, how should I?
So it becomes a function with multiple arguments.
Yes.
Same
Yes.
function.
Yes.
That is why it's
Okay. Are you okay with this? So we can say define min function. Let's call it my min. Okay. Or my min max. Okay. What it does is it takes any number of args and computes the min and max. Okay. So let's just give it a name as min equals sys dot max int, and max equals minus of sys dot max int minus 1. Now for a number in args, if that number is greater than max, we assign that to max. If that number is less than max, less than min, we assign it to, okay? So this is a little bit of a gocha. Okay, we can say this, and then we can go to else, elif number, or we can just simply say if. Okay, that's better, because if there are two numbers filled with equal values, okay, if number is less than min, so these guys, I think a better thing would be I type it somewhere else. I say, let me increase the font. Define, so we are writing a function which can accept any number of arguments. Okay. Why? Because sometimes you require that way. You don't know upfront how many arguments are going to come. In those manner, okay, this is how we are going to do. And we can say if in the same spirit, and we can say number is less than min. We can say min equals number, and this has to be removed, indentation finished, and we can say return and min comma max. Okay, so now we have written this program which goes through all the arguments, and okay, so my min max, so if I pass 2 3 4 0, okay, what will be the output? M capital, all right, 0 comma 4. What? Yes. Yes. That's where that if else condition comes into play. Okay. Now, if you do that, if you don't pass argument, it is returning us the min and max. How come the max? Yeah. It's returning the inverse way. Okay. Now, is that good? Everybody okay with this? Comfortable? No? This one? All right. So I will send it to all of you. And here we go. Okay. I think somebody's screen is shared. I need to change it to. Yeah. So once I'm done, let me know, because what's happening is I'm leaving it to the person who is sharing the screen. And that's a little dangerous. All right. So this is was variable number of arguments. Now another one is variable keyworded arguments. So sometimes you can call the function like this. Sometimes you can call a function, instead of feeding in only the value, you can feed in the keyworded argument. You can say name equals to value, comma, name equals to value. All right? Sounds good? Yeah? Sounds good, Jagdish?
Yeah.
Sridhar? So basically, in some cases, we can basically pass a keyworded arguments. It's like a hash table which we are passing. And those variables we can access later on in this fashion. Okay? We'll go into more details at later point of time.
So you can print this percentage as well.
Yeah,
Print key percentage.
correct. Okay?
Can you repeat this?
Yeah. All right. So variable argument is clear. Similarly, there is something called variable argument dictionary. Okay, keyworded argument. So that there you put double asterisk. So when you put double asterisk, it basically expects the variables in this format. So you will call this function like key equals value, comma, key equals value, and so on. You can put in any number of key values. Okay, and then you can iterate over arguments using kwrgs.iterate items, and then we can print all of this. So this is something you missed, which is not there. So Sachikant, this is something you missed. So here you can have variable number of arguments, and before that we were saying you can return any number of arguments. You can return any number of argument which is not there in Java or anything. Okay. Okay. In the 7 or 8. Yeah. Yeah. That makes our life easier. So you can return multiple values like this. And here you can say x comma y equals this. Easier example was our example, what we were talking. Okay. Here what we were doing is we were saying this is some initial value we have assumed, and then we were going through arguments and we were returning this. Okay. Other thing is, in case you are not sure how many arguments are you going to accept in your function, you can say put asterisk here, and that means any number of arguments. You get a list of values, and next is you can have keyworded arguments. You can have keyworded arguments like this. Okay, look at this syntax. So here we are talking about two aspects here, which means we can have keyworded arguments, and then you can iterate over like this. Okay, and the way we can call these kind of function is name equals something, name equals some value, comma, some other value, and so on. So this way you can basically pass a full dictionary to the function. All right.
So key value will be the bigger word.
Which one?
Key value.
No, these are our variables which we are saying for each key value in this and this. Okay, you'll see it further. Don't panic if you don't understand it. Okay, so this way you can have something called keyworded arguments. Yeah. Provide the values in that. So I'm making a presenter. Yeah, there you have this, okay? Yeah, when you're calling, right? Huh. Yeah, now you call this function. You're not calling that function in the same program. Let's go back to your program. There you write my min max, then 1 comma 2 comma whatever values you want to feed. How many ever value you want, you can execute. Okay. Please use that Notepad++ or some other editor, because WordPad is actually pretty bad. It will every time you will put double quote.
Auto-indent, right?
Huh? Or yes, yes. Not only that. Not only that, this guy will actually corrupt lot of things. If you put double quote, he'll tilt them, and then Python will give an error that is a, yeah, this is correct. Yeah, go ahead. The good part about programming is you don't have to ask generally. Go back here. You have to say import sys. Import sys. At the top, first line of the program before def, you have to write import. Before that. Import sys. That's it. Because I'm using Maxent here, right? So that for that we'll talk about this a little while afterwards. Okay. You have to say print. You have to say print in front of this. Yeah, you can say print.
Yeah, print my min max.
Yeah. Perfect. Perfect. So it's running now. So basically, we talked about the variable argument, variable keyworded arguments. And now there are functions which do not return anything. We call them non-fruitful function, and they return none as a value. If you try to assign a variable, say you x equals to my function, and this function is not returning anything, then we call it that then x will be none. Okay. Now there are few cool things which you do not get to see elsewhere. Like in C programming, you could pass something like pointer to function and all. Here, that's not a big deal. Here, let's say there is a function called circle. There is a function called circle here. You can see that. And all circle does is whatever name you give it, you say that name is the circle. That's all. Now, there is a function called shape. Shape accepts two arguments, shape and name. Now it says that I'll call the function called shape with the name. Okay. And then it will basically, you will pass the circle and it will call the circle. You don't get it? Yeah.
Which you are taking under the function. I'm using the same name for the. It's a predefined function.
Which one? Circle? No, I've just created a function. So what I'm trying to do here is I passed. So first I defined a circle, I defined shape, then I passed circle as argument. We passed normal values like 1, 2, 3. Instead of that, I passed the circle itself, the definition itself. Because as I told you that a function is name is itself a variable which can be passed around. Okay. So I will try to run it. I'm just hoping that it works fine. Otherwise, I'll have to copy paste it. It's not copy pasting actually. So let's say we define a function called circle. Whatever name we give it to circle, circle says print name, and name is circle. Okay, that's all it does. Now let's say we call it drawer, something that draws a shape, and we call it, okay, draw the shape. Okay, and in that we are passing a shape, and all it does is it calls shape and with some name. Call, okay, new shape. Okay, something like that.
Shape. You put share.
Shape. All right. Now the moment we call here as drawer. Okay, and we pass circle to it. Okay, now what will happen? And now let's say I'm defining another function. The function's name is square. Okay, the function's name is square. Let me call it square. Okay, now you can see that. So circle is there. If I call circle just like that, okay, so circle is, ring is a circle. Okay, ring is circle. All right. Now, sounds okay? If I ask a drawer here, if I ask drawer to draw the circle and say, let me also create. So I have three functions. One is circle, other is square, and third one is drawer. So drawer can draw anything. Okay.
You need to make yours a circle.
Oh, sorry. Who is the gentleman? You should inform me, because that's what is getting recorded, whoever
Yeah.
screen it is.
I just know now that's why.
Okay. All right. So now we have a drawer. So drawer, if I pass a circle to it, new shape is a circle. Okay. Whatever I pass it to, it will basically execute that function. Okay. It's like passing a function pointer as an argument. Okay. So whatever I draw, whatever function I can pass to drawer, it will execute that one. No? Confused? Baju?
The drawer function, that
So if you look at drawer, what it does is it calls whatever argument you give in, it calls that function.
but that function is not there.
Shape, that's the argument. So shape is being called like this.
Actually, circle with new shape is being
No, confused utterly, Vidpal? Confused. Okay. So what am I trying here is
If you change the shape name to function call.
okay, or let me call it its name. We are calling it shape caller. Okay. Okay.
Shape function.
Yeah.
But shape also.
So shape caller, any function you pass as argument, all it does is it calls that function. Okay. And from caller. Okay. So what it'll do when we passed circle here, so what it is going to do, it is going to call circle with this argument. If we pass a square here, it will call a square with this one. Now you can see that. So now whatever we want to execute here, we want to say shape caller, and we give circle here. Okay. In the same manner, so it says that from caller is a circle. In the same manner, a square. Okay. All right. So this is a little tricky thing. So when we lay out the UI, when you think about a UI, So what happens when we are rendering the UI? Our UI, normal UI, say here, each thing is a glyph. It's a glyph. It's a glyph. Whenever we are rendering a UI, this 12 is a glyph. Everything is a small components on the UI. And the painter is a class which accepts these as the argument. And whatever argument you pass, it calls paint on that. It calls paint on that. And then it recursively prints. So basically, the graphics work that way. Whatever argument you give, it executes that. Or a better example would be that we talked about two ways of computing summation, right? We had two ways. First way was we defined a function. Where is my function? Yeah. Here there were two functions, right? There was this function and there was this function. Okay? To compute the summation of a value. Okay? Now we want to call any of these. Okay? So we can write a function called caller. We can say define caller and we call it algorithm. Okay? And here is the value. Okay? And what does caller do is it calls the algorithm with the data you are providing here. Okay? You are calling algorithm with the data. You have two algorithms right now. One is summation up to value, which uses recursion, and there is summation up to this value. Okay? You have two algorithms. You want to use these algorithms automatically. Or you want to basically, without, whatever user provides as a function, you want to call that. Or let me say that, how should I say? So, whatever you pass from external, you want to execute that function. Okay? So, we can say caller equals to algorithm like this. And then we can say caller, and we can pass sum up to this value. Okay? And we can also return here, okay, sum up to comma, say 1000. Okay, sum up to is not defined. Why? Because we have not defined it yet. Okay, sorry. Yeah, so here it has done the computation part. Did it work? No, it did not work. So sum up to okay. Mm-hmm.
Put it in some variable and print that variable.
So that's what you tried at H.
So let me just try here. I think there is some other way. Some already we have defined it. Okay, so we pass this. Yeah, it's working now. Some printing issues only. All right. So yeah. So now clear, right? Now you can also switch between the two easily without ever knowing that something is going on. Okay. We are switching between algorithms. Say there is a library of 100 sorting algorithms. You want to call it on a data. So you can provide a function which is a caller which can switch between the values. Okay. So that is a function argument. Okay. Now this is interesting. This is a little different way of doing things. There are some interesting inbuilt functions. such as filter. So this is inverse way of doing things. So let's say there is a filter function inbuilt. What does it do? What it does is whatever function you provide as argument, okay, what it will do is it will execute your function against the array you provide, one value at a time. So there is an inbuilt filter function which does it for you, and it's very useful. If you have a big array of values and you only want to, we want to create a new array of values by filtering these. So you can pass your function, the qualifier, we call it qualifier, and you pass the array, and this qualifier function will be called on each value. And how does this qualifier function looks like? It looks like this. We say def is even x and return x percentage true. It has to return true or false. So all the values for which this function is returning true, all those values will go into output. Okay, so you can see 1, 2, 3, 1 qualifies for is even, yes or no. Will it return true or false? False. So 1 does not go in the output. For 2, it returns true, right? Then it goes in. Okay. Yeah.
Basically, it doesn't return anything. It returns none, right?
Which one? No, it returns an array.
So easy one, right? If it is an even, it returns that value.
Yeah.
Right. But otherwise, it returns none. Or
Who?
If there is no value which is
It will empty the array.
empty.
If there is no value which is qualifying here, then it will return an empty array.
Easy one.
Is even has to return true or false. That's it. There is no third value it has to return. If it returns true for that particular value, then it is put into output. And most important, why we are discussing this function? Why? Can anybody tell why exactly? Yes. And where exactly this fits into?
Function to data.
Passing function to data. Exactly. So this is the one paradigm which takes your function to the data and executes it, which means it is used in distributed programming, which means big data programming, MapReduce. Correct. So here what we are doing is we are giving out our function. Please execute this at your own luxury. Please execute this filter function at your own luxury. That's why Apache Spark provides these kind of functions to you. Okay. So is that okay? Yeah. Is provided by the.
Now I understand.
Okay.
Listen something here.
Okay.
Filter is a function which, if it is a true, it returns that value.
Yes.
Now I got.
Debashish, you got busy with something else?
There is some new changes.
Okay. So this is important. So basically, we create a function called filter. We don't create this function. It is inbuilt function for which we pass our qualifier function. Okay, it's just a normal function which has to return either true or false. And your function, the qualifier function, has to take only single value at a time. And then you pass the full array, and it runs this against the full array. Yes. For each value. Now, can somebody tell me if this array contains 50,000 elements, how many elements will come out? More than 50,000, less than or equal to 50,000? Less than or equal to 50,000. Okay, irrespective of what filter function we pass. Okay. So, should I give a demo? Yeah. So let's say we write a function called isEven, okay, and we pass isEven except one argument only, and we return x %2 equals to 0. Okay, let's try isEven working or not. So for 1, it's false. For 2, it's true. For 0, it's true. Okay, sounds good. Now let's have an array. Let's run filter. Filter is even. We pass is even function, and we say 1, 2, 3, 4, 6, and all of this, and we okay. So we did not have to write for loop, or we did not have to write our own logic. Okay. Now, good part about this kind of programming is, say filter there's a filter function provided by Apache Spark. Okay. What it does is, whatever function you are passing to filter function, it will execute this function parallelly on array of elements. Okay. If you have 50 machines, is even function will be copied to all 50 machines parallelly, and part of the array will be processed parallelly on all the machines. Now that is the difference between functional programming and non-functional programming. These kind of functions are designed for taking the code to the data, not bringing the data to the code. If you had been writing your for loop, that will be impossible to break. Computer has no way to break it down, and there's no way to do that.
Distributed aspect.
Yes, this is what it is. This one, yes. So dynamically, as in, if you have, say, argument, say you have already defined an array like this, so you can give the argument like that. Okay. So you can say.
Isn't that like he asking something like streaming? So we keep entering like this.
What?
He's asking something like streaming. Here we pass on the data, right? We want something like.
Yeah. So those are the tools you can always create on top of it. Okay. Those are the things which OS has to provide. Apache Spark provides it that way, that you can keep on entering the value all the time and then executing it. Okay. So that way, that's a completely, totally different way of thinking about it. Okay. So there, yeah. All right. Now there is something called map. Map is provided by Python from in the language itself. Is a function map. What it does is, it takes your array, it takes your function, then for each element of this array, it is going to run through your function. Okay. It's like you have provided a machine, you have provided your data, you are telling the system to run the data on your machine one element at a time. So it will basically a translator of one array form into another array. Okay. Now say here we are doing a square of this array. We are doing a square of this array, meaning we are going to do 1 into 1. And how it's happening? So we call a map function. Map is an inbuilt function provided by Python to you. So we are saying map. Then you are saying, you define your translator. What does your translator does is take an argument, square it. Square it by it is multiplying by 2. Square is double asterisk. Okay. So double asterisk, and so it will basically, whatever value you give it, it will square it and return. Now the same function I passed here, and we gave a data. Okay. Now what will happen is, for each element of this array, for each element of ARR, we are going to run mymap function. Okay. And that's how it's going to work.
Okay, so what is the basic difference between filter and map?
Filter basically puts only those elements which qualify. Here, it puts all the elements of a array.
Yeah, it's doing a compute.
Yes, it's doing a computing here. He's doing a translation of the data into something.
Filter is reduced, not
No, filter is not reduced. You will see the reduce now.
Okay. We're ending that.
Okay. Now there is something called reduce. And this reduce is little different from what we have read in Hadoop MapReduce. This reduce, all the functions which we define as our reducer take only 2 arguments, not more than 2. And they return a single value. It's like 2 values being converted into 1. And all the elements you are passing here, they will be combined recursively into single value. So you can see my summation is only summing up 2 values, but this function will compute the summation of all the values. It will take 2 values at a time, combine it, 2 values at a time, combine it, then the resultant will be combined further in this manner. Okay. So for example, in this slide, it took 2 values, 1 and 2, so called your function, which was basically returning the summation, and then it took 2 values, computed the summation, and then again it took these 2 values, computed the summation, and then returned the value. Okay, and that's how it works. All right. So this is reduce. Now
At my sum, the function which we pass always should have only 2 arguments. Right?
2 arguments. Okay. So it takes our only 2 arguments and then recursively applies your function until it converts it into 0. Okay. Packs it every time it keeps on reducing and returns it. It converts it to a single value. Okay. So that is the difference. That is reduce function. You missed a lot. Okay. So where were you? At what place were you?
Multiple star.
Okay. After that, we talked about filter function. Filter function is inbuilt function from Python. It takes a function as argument. You have to define this function. And this function tells, your function have to tell true or false. Now, what filter does is whatever function you pass and whatever data you pass, it executes your data against your function, 1 value at a time. In case your function said, yes, let 1 go in the output, it will put it in the output, otherwise not. But your function here is even. What it does is, any value you pass, it basically finds out whether it's even or not. In case it's even, it returns true, which means it will only put those values which are qualifying is even. And essentially, it will only put 2 and 4 in the output. Okay. So filter is taking big data, converting it into small based on a filter. Now, in the same way, there is map. Map is basically translating one array into another array using your function. Okay, translating one array into another array using your function. And your function basically takes a value, returns another value. So your function here is multiplying by 2. So 1 will be multiplied by 2, which is 2. Then 2 will be multiplied by 2. So for each value on the array, your function is going to be called again and again. So you can think of map as a for loop over the array where your function is being called again and again. All right. Same is the case with filter. Filter is going to call each and every your function again on this each value, and in it will only put, if your function is saying true, then it will put that element in the output, otherwise it will not put. Okay. So that's a segregation. All right. And then is reduce. That's what we are talking about. Reduce is interesting function, and it takes a little bit time to realize that reduce is not very useful as it looks like. I'll show you why. Reduce basically converts a lot of values into single value using your function. Now, this function of yours, which is there, it has to take only 2 arguments, while reduce function takes array of any number of variables. Now, how does it convert an array of values into a single value using your reduce function is this way. Say you are passing 1, 2, 3, 4. So first 2 values are picked up. Your function is called, your function takes 2 values, right? Your function takes 2 values and that converted into a single value. Now again, these 2 values are picked up and then your function is called on that one, and you got 7. Now 3 and 7 will again be combined together using your function. Okay, that is 7.
So addition is simple. The division.
Division is not. Division is not. Yes.
Reduce is not work.
Yes, exactly.
Over or top.
Yeah. Similarly, we are able to happily find summation. If your function is minimum, you're trying to find minimum of an array of values. Okay. So will it work? If we have defined minimum x comma y, return x, whatever is smaller, it will work. So again, in that same way, minimum of 1 and 2 will be 1, right? 3 and 4 will be 3. Now 3 and 1, minimum of 3 and 1 is 1. Similarly, max, will max work? If you have a function called max, which is computing maximum of only 2 values, can you apply that on an array of value recursively? Let's see. 1 and 2 max is? 3 and 4 max is? Max of 2 and 4 is? 4. Right? It will work. Okay. So recursively applying min and max function, that's where comes a definition of cumulative and associative. Okay. Your function which you want to put into max should be cumulative and associative. What does it mean? It means that either you call, say, A, B, C, 3 values are there. Whether you call your function on AB first and then resultant of A, B, and C, or you call your function first on AC, whatever is the result, you call it with the C, or you call on BC, whatever is the result, you call on A. If your function qualifies for it, then your function is cumulative and associative. All right. And this is a big data definition of things, and it's very much useful. Your whole Apache Spark works on these 3 functions. Right. Okay. Filter, map, and reduce. And similar philosophy also applies on combiner of your classic Hadoop. Okay. Therefore, it's very important to understand what are the functions that are okay. Now, question to all of you is, which of the following functions are okay for reduce? Anyone? Yeah. Min-max is, we have already said that those are okay because you are able to call.
I don't think the average of n numbers equal to.
So he says average is not okay. You are saying average is not okay. Who else? Try. 1, 2, and 3. What's the average of 1 and 2? 1.5 and 3. What's the average? 2.25. Now let's do average of 2 and 3. 2.5. And average of 1 and 2.5 is 1.75, which is wrong, right? So therefore, average is not cumulative and associative. Therefore, we cannot use average as our recursive function to combine all of the values together. Instead, what will you do is, and can anybody tell length? Is length or count? Is count a good function? Not really.
Right?
Not really. No. Because see, count every time will return 2. Count A comma B is always 2. Okay, but you can always break down count into a associative function of summation. You always can convert it. Yeah, you can always convert that. Now let's come back. So now we have proved that average function is not cumulative and associative, and hence is not good for map and reduce. Okay. So everybody okay with this? You, sir? No? So we are talking about here the reduce function, which takes 2 arguments. So if you have an array of elements and you have to convert it into single value, and you have a function which takes two elements at a time. So how does this do it? It takes two elements at a time, convert them into single value, and then take those value, keep on converting it until it converges into single value. So Prithpal sir, what do you think? Is average a cumulative associative function? Yes, try it out. Try with 1, 2, and 3. Last one. Who thinks that the last one, the fourth one?
Square root x square plus y square is not equal to square root x square plus square root y square, right?
Try.
You are right.
Try. Try with x, y, and z. So the value of, if you call x, y on first value, it will be this one. Now this is your z, right? Sorry. Now let's call it u. Okay. So u square plus z square is how much? X square plus y square plus z square, and then square root of that.
Square root of the intermediate squares, right? Square roots.
All we are trying to do is we are trying to compute square root of summation of squares. Square root of summation of squares of values, and for that we are using this function. Does it make sense? Okay, so let me try to show you. Let's say we have x1, x2, x3, x4. Okay, what we want to do is we want to say square root of x1 into x1 plus x2 into x2 plus x3 into x3. This is what we are trying to compute. x4 into x4. This is what we are trying to compute. We are trying to compute square root of summation of squares of all the values. Yeah. So now let's say we pick up.
Which is not equal to square root of x square.
Now let's say for a equals, let's x1 plus x2 we gave to our function. What will it be?
Yeah.
Or let's just take three values. That will be easier to. Let's just take three values. That will make our life easier. Okay. This is what we are trying to compute. Now a equals square root of
x square, x1 square.
x1 square. Okay.
Plus x2 square.
Plus x2 square. Okay. x2 square.
Hmm.
Now in the second run, okay, second run,
x2 square.
it will be square root of a into a plus
a square plus x.
x3 square. Correct?
Hmm.
It will be this one. That's okay, right? Now let's expand it. Okay. Now square of this one is this, right? It will become this.
No, wait. Just control Z. No, A is what?
A is this.
We have to replace square root of x1. Yes.
Same thing, right?
Same thing, right? Which means
That whole square.
yes. Which means a square equals to this one.
Okay, yeah, got
Got it?
It works.
Okay, now it works. Alright. So yes. So the last function is correct, which means this one fits into the reducer, while this one does not. Okay.
Same way, cube root of x cube also will work.
Yes. But square root of cube is not work. Okay. So think about all these things. So basically, when you have a big data and you want to summarize it, that too distributedly, meaning using thousands of machines, you want to do it. So on some machines, there'll be some piece of data, some other machine, some other piece of data, and you want to do it recursively in the same spirit as the way we have done here. Okay. So we'll apply one function here, then apply another, then apply another. We'll get a singular value by recursively applying the same thing on two elements at a time. If you think about sorting problems, when we say divide and conquer and do sorting, the way we do it is at the end of it, whether merge sort or any of the things, we basically divide the data into parts and do it on 2 values at a time until we get a single value. Okay. So all these 3 are okay. The first one is not. Okay. Now, who can match this result? The filter has how many output values? Filter has single value. Who? 3. Okay.
Reduce has a single value.
Reduce has a single value. 3A.
2B, C. 1C.
1
C, 2B,
C.
3A.
Correct. And 2B. Is it okay? So when you run a reduce function, you get only a single value. While when you run a filter on an array of values, you will either get equal number of values or less number of values. Why? Because filter will only return the values for which you are returning true. Otherwise, it will just put everything into output. Now, map will return as many values as you have input. Okay. While in case of Hadoop MapReduce, it will give out more number of key values than the input. Okay. Keep that in mind. So question is, it's a discussion question. How are map and reduce and filter distributable paradigms? These are paradigms. These are paradigms for distributed programming or big data programming, as we call it.
Because they are associated, so input can be broken down into smaller.
Yes.
Cumulative and associative.
There, here, that's only reduce, but we are talking about map and filter also. Okay. Thing is, all can work on a smaller part of the data. If we had written our own for loop, right, and doing some processing, we require the whole data on the same machine. But here, it can work on any range of data. Second, divide and conquer. Okay, in part of the data, yes. And third is the logic can travel. Our logic travels the way we provided function definition. We are saying here is my function, here is my data. Run it irrespective of either the local machine or remote machine or wherever you want to do. We don't care about that. So we are making the logic travel rather than data travel. In a classic sense, what we do is we read the data, we run a for loop, we run all kind of logic, then we print the data. Here we are not doing that. We are saying, here's my logic, here is my reference to data, you do whatever you want to do. Whether you want to run on 10 machines, 1 machine, 100 machines, 1000 machines, that's the way we. So this is a different way of thinking about programming. Okay, this is a different way of thinking about programming. So when somebody asks me, can you square an array of values? If I provide you an array of values, I generally think in terms of a map. I'll just write my, yeah.
But how do you print it? Once you create an object,
yeah.
how do you print that?
So inside map itself, I can keep printing the after squaring, right?
Map.
Yeah,
In the function itself.
In the function itself, I can print. Or I can, basically it depends on what people are asking. I'm asking that, can you square my array of values? I can. I'll just use a map function. So that tomorrow, if we are going on to some distributed paradigm, it's easy to break down my logic and run it. Okay. Irrespective of the size of the data, my program will always work. Okay. Similarly, when you are using a sort function. So if you're using a classic sort function, if you pass the way you want to sort it, so you do not deal with the data. All right. Then there's something called anonymous functions. Okay. Anonymous functions are really, really cute. So here we generally define a function, right? We wrote def fx, then return x square. This definition you did not see because we were always doing it indented way. You can write in the same line. Okay. Now, there is some similar way. We have similar definition called g equals lambda x colon x square. Okay.
That's great for lunch.
Okay. No, this is the last slide. Okay. Yeah. But yeah, we can break. No issues. Yeah. if that's the case, let's break. All right. So we'll discuss lambda function after lunch. And yeah.
I'm trying to filter out the square root of x square plus y square, but I'm not able to print those values.
What? You're trying to print?
I'm using this function. This is my function.
Mm-hmm.
And I'm doing a filter of, but I'm not getting anything. It just says filter object does this. But how do I get the values out of it?
Where is your where is that?
Oh, print filter.
I'm just seeing what is going on.
Print, you have to give brackets and y.
Yours is a 3.
Yeah.
You have to change something because I've run exactly same code.
So it says filter object. It says you can't print filter object. I don't know why.
Oh, you have to go like this.
Afternoon object-oriented programming.
What?
Afternoon.
Mm-hmm.
What?
No. The basics will keep on going a little bit more.
Print I. No, bracket.
Okay. You try it.
But
I think it should work. All right. Now let me stop the recording and